Very good morning and welcome you all to the NPTEL online certification course on Advanced Distribution System Analysis and Operation. And today we'll be talking about distribution network reliability. One of the very important topic that we are going to discuss today is value of loss load calculations. Now imagine due to any unwanted event and if the load is not being catered or you have not been given access to electricity, so that means load is not met, okay. But we take it as an kind of acceptance, or maybe kind of we accept it, fine, there is no load today, is being catered. But how do you value it? For example, if there is an industry and if there is a loss of load, so that means we lose millions of rupees for that, okay. And if it is a semiconductor device company, then probably any loss of load, leads to huge loss. And even if a day-to-day life, if you miss the load, how to value it? What is its value in rupees or dollar when there is a load is not being met or being lost or being disconnected? So let us focus on value of loss load calculation. So what is value of lost load? Value of lost load, that is VoLL acronym, is a monetary measure, that captures how much consumers value avoiding a power outage. Means if that would not have been faced, or if that outage would not have been faced by a consumer, then how much value that gentleman would have added. Or reverse, and because of there is a outage, how much money or monetary value, we have actually lost it. So value of lost load, that is VoLL, is a monetary measure that captures how much consumers value avoiding a power outage. It expresses the willingness to pay WTP for maintaining electricity supply. Means whenever there is no electricity, what we do, I can have a backup system, I can have a diesel generator, I can have a battery. So this is what the additional cost I have to invest to make sure that I am not losing electricity supply at any given point of time. So they are defined as like, rupees or dollar, but for better understanding, if you say it is dollar per hour, value of avoiding 1 hour of outage, dollar per kilowatt hour, that is value of consuming 1 kilowatt hour during outage condition. Now the key insights, although dollar per kilowatt hour resembles electricity pricing unit and VoLL is not a price. Retail prices reflect cost of production. VoLL reflects value to the customer, often higher than retail price. Most VoLL studies assume full outages, 0% supply rather than partial curtailments, and VoLL use VoLL, that is VoLL multiplied with kilowatt hour unserved will give me estimated cost of outage. This is used in cost benefit analysis, that is CBAS, to justify grid upgrades or reliability programs. Now what are the challenges? VoLL is not a single value because it varies from time to time, for customers to customer, from load point to load point, and it varies with customer type, industrial, commercial, residential, end use, medical device versus lighting, context, time of the day, duration, geographic region, prior warning, etc. Categorizing the component of VoLL, this section breaks down VoLL into cost categories that differ by sectors. For industrial or commercial customers, direct outage cost includes ideal labor, resources, delayed or halted production, equipment damages, health and safety risk to employees. Indirect cost, supply chain disruption, example parts not delivered to the client and so on and so forth. Now for residential customer, direct outage cost includes activity disruption, that is missed work, lost leisure, and then property loss, that is food spoilage, burst pipes, etc. Health concern, example loss of medical device functionalities. Indirect cost minimal but may increase with trends like remote working. Now mitigation cost, what we need to do? We need to have, not to avoid that loss of load, I need to have backup generators as I told you earlier, protective gear, grid hardening efforts. So this reduces the VoLL because they reduce the impact of outages. Customers with mitigation equipment experiences less loss, and this cost can also be used to estimate VoLL indirectly, a revealed preference method. Now let us understand a microeconomy framework. This framework explains VoLL using economic theory, especially demand curves. The main concept, people don't value electricity directly, they value services powered by electricity, AC, lights, internet. These services vary in importance, so value of electricity use is not constant. Demand curves, consumers have a downward sloping demand curve for electricity. Willingness to pay, that is WTP, decreases with more consumption. High value uses, example breathing machine, occurs at the top of the curve. Low value uses, for example video games, occurs at the bottom. So I mean, due to any reason, if you are not able to play a game due to loss of load, I mean that's not going to cost you much. Now moving to a microeconomic framework, and the figure 30.1 shows demand curve for electricity, as you could see how it has been explained. So you can see that electricity consumption and electricity price, all right. So this is how the prices keep on dropping, that is dollar per kilowatt hour, and we can say the cost from Q1 hour to Q2 hour now got increased by a small value. So indirectly I can say it would have been, let us say 0.35 probably, and where the Q1 hour, when you move to Q2 hour you have to pay 0.4. And you can also see the electricity consumption versus P, the retail price of electricity, and this is how hospitals, households, the cost is keep on varying. So theoretical and conceptualization of demand curves corresponding to a specific individual and the different end use of electricity left, and aggregated demand curve of an entire region that might correspond to different end consumer of the electricity, which has been presented in the right hand side. So let us understand what the left diagram talks about. So an individual's demand curve where consumption drops from Q1 hour to Q2 hour as price rises from 0.20 to 0.40. The curve reflects the customer's willingness to pay for various end use like internet, lighting and heating. So when you move closer and you are ready to pay more and more when you move from right to left. Now the right hand side diagram, an aggregated demand curve for a region built by combining different consumers' preferences and their average value for electricity services. The area under the demand curve above the supply price, assumed as the social marginal cost, a horizontal line, represent the consumer surplus, that is the value consumers gain from electricity use beyond what they pay. Now, during an outage, the consumer loses access to electricity, and the VoLL is estimated as the lost consumer surplus, that is the area between the demand and supply curves, up to the amount of foregone electricity. Now, slowly moving to one more demonstration, illustrate outage cost VoLL as lost consumer surplus. For an individual, a complete outage results in a total loss of electricity consumption. The VoLL is shown as the entire area between the individual's demand curve and the flat supply curve, that is price equal to social marginal cost from 0 to Q units. So, this is how actually it has been defined from 0 to. So, this is basically consumer surplus lost, that is in full outages, and every level you could see the cost is keep on increasing from this point to. Now, in the right hand side you can say for a reason experiencing a rotating outage, only a fraction of customers are affected, okay, not all, but a fraction of customers affected. So, VoLL is shown as the average lost surplus across the affected population, and this represents partial interruptions, not total load loss. So, the area under the curve is smaller than in the individual case. Now, the difference in area between the graphs highlights the scale of the impact. A total outage of one user causes complete utility loss. A rotating blackout shared across many spread the outage's cost, but still creates a significant cumulative VoLL when aggregated. Now, here we discuss how VoLL based decisions can be economically efficient but socially inequitable. Now, it is quite important because efficiency issues, rotating blackout do not distinguish high versus low value usages. Circuits serve mixed customer type, making prioritization hard because it is quite difficult to prioritize. Equity concerns, willingness to pay, that is WTP, equal to VoLL, but also depends on income. A rich person might have high WTP for air conditioning. A poor person might need electricity for medical devices but have low WTP, relying solely on WTP, that is willingness to pay. Unfair outcomes, that is hospital with lower paying patient get cut off. Imagine you have 100 beds and where you say if you want uninterrupted supply all the time, then you have to pay double the charge. Probably 50% customers may go with a lower cost option, which is socially inequitable. Okay, only richer can afford to pay extra, that is willingness to pay WTP, to have access to electricity all the time, around the day, uninterrupted. The demand response is a better alternative to me, where programs like dynamic pricing or interruptible load contracts pay consumers to reduce low priority loads, avoid needs to random outages, but this can't address T&D infrastructure decisions. We still rely on cost benefit analysis using VoLL. Now, electricity as a public good, electricity reliability is non-rival or non-rival. One person uses does not reduce others. non-excludable, hard to provide different level of reliability without costly infrastructure. The market failure occurs because of no functioning market exists for how much reliability you want. I mean, no market can say, are you looking for what level of reliability, So we don't have market of that structure as on today. Everyone gets the same reliability. If it is there, energy for everyone, it is there. If it is not there, it is not there. So VoLL is needed as a regulatory pricing tool to estimate outage cost and also justify the public investments comparison. If there is a milk storage, the market raises prices, but electricity can't function like that. It has no easy substitute and blackouts affect everyone. So we cannot afford to have a scenario where we can't say that we can allow electricity not to be available to a customer, and there is no substitute to that perhaps actually. So everyone has a right, the basic right, like food security, electricity security is also a fundamental right of any individuals of any country. So if you refer a little bit about the brief history of VoLL literature, origins in the 1970s, reliability awareness sparked by oil crisis. Economic research into the value of electricity reliability began in 1970s, largely triggered by the oil crisis and a series of major power outages. Example 1977 New York country blackout. Early VoLL related discussions were more engineering focused, emphasizing generator reliability rather than distribution or customer centric analysis. Now, models used by vertically integrated utilities focused on load forecasting, generator outage probability, construction timelines, targeting a 1 day in 10 years LOLP, that is loss of load probability standard for planning. Now, emergence of cost benefit analysis CBA in reliability. By the late 1970s and early 1980s, researchers began introducing CBA frameworks linking system reliability via LOLP to economic cost of outages. Key studies showed that the then standard 1 in 10 LOLP might be overly conservative, leading to overinvestment in capacity. Now, the customer loss functions were introduced to estimate economic damages of outages by relating electricity usages to GDP or industry productivity. Now, these frameworks helped define early conceptual models of VoLL even before the term itself was widely used. Now, let us understand a little bit about VoLL metric in deregulated market in 1990s. The term VoLL, value of loss load, was formally introduced during the UK electricity market privatization in the early 90s. And it was used to justify capacity payments, to incentivize generation investment in a market driven model, replace centralized planning with market mechanisms for reliability. In the UK, VoLL was administratively set at 2.35 pounds per kilowatt hour. In 1993 and 94, aligning with earlier academic estimates. Now, with the spread of electricity market deregulation globally, VoLL become central in capacity markets and scarcity pricing regime. VoLL was embedded as a key parameter in market clearing and investment signals, Studies during this period included, you can refer to Hogan 2013 on scarcity pricing, Fryer et al. 2013 on regional VoLL estimates for US market, and you can also refer to Skorder and Cooksenkris 2015 on European policy implications. Now, measuring the VoLL in practice, that is proxy or microeconomic modeling, we can experience bit of merits and limitations. The advantage is easy to compute using public data, scalable to regional or national planning, and the limitations are misses consumer level, heterogeneity, and cannot capture subjective reliability evaluation and fails to account for non-market effect, comfort, inconvenience. GDP based method, that is VoLL, equal to GDP upon electricity consumption, that is kilowatt hour. This assumes a proportional relationship between energy and economic output. Retail prices as VoLL. In some policies or simplified studies, the electricity tariff is assumed to represent VoLL, typically a lower bound. Production function models and CGE, computable general equilibrium models, simulate the impact of electricity shortage on sectoral productivity effect, either it is comfort or inconvenience. Now, there is also survey based strategies where the strengths can segment VoLL by sector wise, outage characteristics or demographics. The limitations are subject to hypothetical bias, and consumer may find valuation scenario unclear or sometimes unrealistic. It uses questionnaires and stated preference methods to directly ask consumers how they value uninterrupted electricity. The main techniques are contingent valuation, ask what would you pay to avoid a short duration of outage, probably 1 hour. Now, contingent ranking, consumers rank different reliability price bundles. Cost questionnaires based on actual past outage events, example, estimating cost per hour lost during a blackout. Now, real performance approaches, interruptible contracts. Now, some consumers agree to reduced reliability in exchange for lower tariff or incentives. Their implied VoLL is inferred from VoLL, which is less than incentive payment upon load curtail kilowatt hour. If a customer accepts $50 to curtail 10 kilowatt hour, then the VoLL will be less than $5 per kilowatt hour. Now, demand curve estimation, where this uses economy theory and observed price response data, assume the demand function follows constant elasticity model, P equal to AQ 1 upon epsilon, and VoLL is estimated as integral dq minus P over a period 0 to Q, where P is the price of electricity and Q is quantity demanded and epsilon is price elasticity. Just let me understand what is price elasticity means. By increase in cost of electricity, you reduce your consumption, and vice versa. By reduction in the cost of electricity, you start consuming more. So, if you start consuming more when the electricity is cheaper, then you are more elastic towards the electricity price. And A is a constant, dq is demand curve, P is the supply price, and Q is foregone quantity during outages. Now, summary of methods. like you have proxy methods, we have survey methods, we have revealed performance method, and you can see the proxy one where GDP ratio, retail tariff, CG modeling, and this is applicable to all sectors. And in case of survey method category, contingent valuation, ranking, past cost recall are different approaches for mainly to residential and industrial customers. Revealed preference method, which is interruptible contracts, demand curves, backup investment, and applicable to mostly industrial and commercial customers. Now let us focus on VoLL estimates across studies. So you can see there is a bar graph comparing VoLL estimates from survey based method n equal to 84, proxy method it is 48, and revealed preference method n equal to 2. So VoLL estimates ranging from $1 per kilowatt hour to over $50 per kilowatt hour indicates high variability depending on the method and the area. So if you use different methods, your VoLL will change as high as 50 times from $1 to $50. So it is important what kind of method we are going to use and what region we are applying, whether it is residential or commercial or industrial. And probably this is a very interesting study that you all can refer. Now, if you see, I mean, different people, different researchers have, estimated, and also different country applications, especially Germany, European Union, USA, and rest of the world have tested VoLL, and you could see it is, it's extremely keep on varying. So VoLL varies widely across user groups and countries. Industrial and commercial usages range from few euro per kilowatt hour to over 250 euro per kilowatt hour. Higher value seen in countries like the USA and New Zealand. Lower values in many European Union member states. Variation due to industrial structure and national economy differences. Depending upon how strong economy you carry, the VoLL estimation also vary accordingly. That is the willingness to pay. So if you see different studies, and especially for private users, range from few euro to 45 euro, influenced by income level and lifestyle factors. So it is also important that if you're depending upon your income group or the way you live, I mean your lifestyle or gross income per year, the VoLL also differs from customer to customer. So with this note, we are coming to an end with a wonderful study of VoLL. Everyone expects the system should be free from outages. So there is no VoLL, but nevertheless, we cannot guarantee that all the time the system is 100% reliable, and hence not to have any outages. Okay, value of loss of load can be estimated depending upon the consumers, depending upon the category of consumers, depending upon the type of consumers like residential, industrial and commercial, as well as the region, countries. The VoLL is going to vary from 1 to 100 rupees, dollars, euros, pounds, whatever you call. But it's a very important concept in reliability study of distribution systems. Thank you very much for a wonderful interaction. Bye-bye.